Hello friends, welcome to Power Plant Guru. In today's video, we will discuss about droop controls and isochronous control for gas turbines. So you can see we have different comments from different users, my viewers, who are requesting for this video. So that is why we are going to create a video on especially on droop and isochronous controls. So friends, I'm a mechanical engineer and having around 20 years of experience in different power plant technologies, and I used to create small fundamental videos for coal-based power plant, gas-based power plant, BOP, etc. And if you like to follow some this kind of content, please subscribe to my channel. So friends, droop and isochronous are two type of controls basically having difference in how they control the frequency or how they control the speed of their turbine. So basically difference lies in that only. Droop control allows frequency to change in response to load. However, isochronous mode is not allowing any frequency to change whatsoever depending upon change in load condition. So basically we can say droop will allow frequency to change and isochronous will not allow frequency to change in response to any load change condition. Let us go in detail. Let's say you droop control normally people operate when they have let's say several machine in tandem operating in a power system. We can consider a case of a refinery where there are 10 or 15 gas turbines are there. Let's say there is any unit trip, let's say a compressor, large compressor at the load side trip. So what will happen if the machines are operating in a droop? All machines are operating in tandem. So let's say 50 megawatt compressor got tripped on the load side. So what will happen that 50 megawatt will be a surplus energy in the total system, and that surplus energy will cause your system's frequency to increase. As you all know that frequency and load or the power has a inversely relationship. So that frequency will rise, and how much it will rise? It will be distributed among all the machines. It will be distributed equally, theoretically equally amongst all the machines. Similarly, I will give another example of droop. Let's say you have a gas turbine and you are running it, you just synchronized it and it is running around, let's say 5 to 10 megawatt. We can take example of 6p. So it is running at 5 to 6 megawatt, and then there is a load at customer side or in a petrochemical or refinery complex, and the load is increasing, and that load is being catered by DO turbine. So if your droop setting is 5%, so whenever you start increasing the load on your turbine from FSNL to full load, your allowable drop in speed is 5%. So you are allowed, your machine is allowed to drop frequency or drop speed at the cost of load. So you have to cater the load, but you have relaxation to supply that energy at the cost of your frequency. So that is a droop mode. But let's say the same condition we talk about for a isochronous kind of machine. So let's say you have 3 or 4 isochronous machines in a complex, and isochronous means they will try to maintain the isochronous, I mean speed. They will try to maintain the speed or frequency. So let's say you are operating 3 machines and there is a sudden load coming up. Let's say 50 megawatt load is increased. So what will happen, all of your machine will try to increase or try to not increase, sorry, try to maintain the frequency or try to maintain the speed, and they will try to compete each other. I will take that load, I will take the load. So what will happen, your 50 megawatt load will eventually come on any single machine, while rest other two machines will not have any load. So that is how the difference in droop versus isochronous operation you can see. So I will reiterate, you have three machines in tandem operating in droop mode. You increased, let's say, load by 50 megawatt. All that 50 megawatt will be equally distributed in three machines with some drop in frequency. While you are running three machines in isochronous mode and 50 megawatt load increase, so all machines, each of the machines will try to compete with each other and try to maintain the speed and take that load. At the time fuel will be increased, but your speed will be remaining constant, and any one of the machine will take that load and rest two will have zero increase in their load. So that is how this isochronous and droop machines are different. I mean, these modes are different. Machines are same, mode are different. That is why people keep normally that machine, all machines which are operating in tandem in a droop control mode. Then when the question comes, then when this isochronous mode is required. So in some cases where you want a very standard speed, let's say on based on some your process requirement or other requirement, you keep a large machine. Let's say all your machines are 30-35 megawatt, and you have a machine at 150 megawatt or 180 megawatt. Then you can keep that machine as a higher machine, and you operate that machine in isochronous mode, while all other it will give a constant frequency kind of a power system, where all other your machine which are running in drop will follow that same frequency. It will be a kind of, I will give a very raw example to understand. It will be like a bus, and let's say your bus means a road transport bus. The big machine is like a bus which will maintain its speed, and there will be small vehicles who are tied to this bus by rope, and they will try to match the speed of the bus. However, if you change the load on different system, but the bus speed will be constant. So whenever your load increases or decreases, your small vehicles will see, okay, the bus is running at this speed, so we'll try to match the speed. So that is how, if you wish, any power system is looking for any stable, very stable frequency range due to any of the requirement, so they used to do it in this way, but that phenomena is very rare. You will not find this kind of processes running all over the world. The droop is one thing which is very commonly used. I hope you people have used droop, and there is a question for understanding and droop and isochronous, so I tried to explain. If you have any questions regarding that, please ask me in comment section. I have described this on a very high level so that it is useful for everybody, and if you want more detail on this, we can have discussion in comment section, where I will try to reply the answer in depth. Thank you, and if you like the video, please subscribe the video. Thank you. Thank you very much. Hello friends, if you have not subscribed the video, please subscribe to our channel. Thank you.